Okay guys, so this is AMI day 1. Part A, we are writing an equation for a tangent line. So that is point slope form of a line. So point slope is y minus y1 equals m times x minus x1. Now they've given you the x1 already. Your x1 is e squared. Your slope is your rate of change. Your rate of change is your derivative. So if we want to find that slope, we're going to do f prime of e squared. So 1 minus ln of e squared over e squared squared. Now ln and e are inverses, so they essentially are going to cancel each other out. So we get 1 minus 2, which is negative 1. Power to a power we multiply, that gives us e to the 4th. So that is our slope. Now we still need our y1. y1 comes from our function. So we are just going to take that e squared and plug it in. So f of e squared is ln of e squared over e squared. Again, those are inverses, so we get 2 over e squared. And so that's our y1. So we're just going to take those and plug them in. So y minus 2 over e squared equals negative 1 over e to the 4th, x minus e squared, and that is our answer for part A. On part B, we're trying to find a critical point. So critical points are where your first derivative is equal to 0. Could technically also be where your first derivative is undefined, but the only thing that makes this first derivative undefined is if the denominator is 0, but the denominator can never equal 0 because that's not in our domain. So we're going to set the first derivative equal to 0. Multiply by the denominator, you just get 1 minus ln of x equals 0. So you're looking for where ln of x is equal to 1. So remember over here in part A, ln and e are inverses of each other. So we're going to use e on both sides. ln and e cancel, so we get that x is equal to e. So we know that makes the first derivative equal 0. What we don't know is if it makes it a maximum or a minimum. So we need to check around it and see what happens. So something easy to plug in is 1, because ln of 1 is equal to 0. So if we do 1 minus ln of 1, which is 0, over 1, we get 1, which is positive. So then we would need to plug in something bigger than e. E is 2 point something, but what we've really got to remember is ln of e is equal to 1. So if we plug in anything bigger than e, it's going to be bigger than 1, which will make the top negative. So since f prime of e is equal to 0 and f prime changes from positive to negative, x equals e is a maximum. Okay, so part C is talking point of inflection. Point of inflection deals with concavity. Concavity deals with second derivative. So we need to find f double prime. So we take the derivative of f prime. Since it's something over something, we use the quotient rule. So we do low d high minus high d low over x squared squared, which is going to give us x to the 4th. Okay, so if we simplify that down on top, multiplying these first two things together, we get negative x. Then we're going to distribute in the 2x and then also distribute in this negative. So that's going to give us minus 2x plus 2x ln of x all over x to the 4th. So really our second derivative is negative 3x plus 2x ln of x over x to the 4th. Set that equal to 0. So we multiply by the denominator, so we're really looking for where negative 3x plus 2x ln of x is equal to 0. We can factor out an x, and we'll have negative 3 plus 2 ln of x is equal to 0. Now remember from our domain up here, x can't equal 0, so we're not worried about this part of it. We're just worried about that part. So we're really looking for add the 3, divide by 2, where ln of x is equal to 3 over 2. E and ln are inverses of each other, so x is equal to e to the 3/2. And so that would be our coordinate for our point of inflection. Now part D, we are looking at the limit as x approaches 0 of the function. So the limit as x approaches 0 from the right of the original function ln of x over x. So if we visualize what the graph of ln of x looks like real quick, it looks like this. So that's why it's specifying we've got to approach from the right, because there's nothing that exists over to the left. So as we approach from the right, ln of x is approaching negative infinity. And then x, as we approach it from the right, is something really small. So you have negative infinity over something really small, which is just going to keep it at negative infinity, or meaning that that limit does not exist. So that is our explanation for AMI Day 1. If you guys need any clarification on some things, please let me know. But I will also do this tomorrow for AMI Day 2, and then the following days, however many days we got to be doing this. Hope you guys are doing well.